ladies and gentlemen. How you going? Good, thanks. Friday Freebies. Today, I thought I would talk to you about friction loss, flow rate, plumbing, and pipe design. Okay? Which is something that I think a lot of people get confused with, they also get overwhelmed with, or they're not aware of in the first place. Okay? So, there's a couple of terms that we need to go over first. Static head. Okay, static head is essentially the level from where you are pumping to the injection point in your tank. So say your pump is sitting at floor level, okay, and the top of your tank is at 1 meter. That is your static head. Your static head is 1 meter. If it's 1.5 or 1.8, your static head is 1.8. If you've got a sump and it's sitting up a little bit and the water level in your sump is up a little bit higher, you measure from the water level to the injection point into the tank, okay? Because the water physically only has to lift that far, all right? That's for flooded suction pumps. Self-priming is another thing altogether, and if it's above the water level, let's just not get into that, all right? It's simple, but let's not muddy the waters, okay? So that's static head. The next is friction loss. So every pipe fitting, every pipe, every surface that the water comes in contact as it's being pushed through the pipe creates friction loss. The smaller the pipe in relation to the flow, so say you have 100 litres a minute, the smaller the pipe, the higher the friction loss, the larger the pipe, the lower the friction loss. The friction loss is measured as a K factor. A plumbing fitting has a K factor, and the friction loss is calculated by multiplying the K factor by the flow rate in an equation to come out with essentially an equivalent level of an equivalent length of pipe that can then be converted into meters of static head. When you add the static head, meters of friction loss, sorry. So when you add the meters of friction loss that you just calculate from your plumbing, your flow rate, and all the pipe work and everything in your tank, and you add the static head, which is your elevation or your lift height, okay? When you add them both together, you get total dynamic head. That is your total head loss throughout the system, okay? So, if I was to give you a demonstration here, I can tell you that this flow curve right here, all right, this is a Performance Pro 1/8 horsepower Cascade, all right. I have a system where I need to deliver 150 litres a minute of flow. Okay, so that 150 litres a minute of flow is about right here. It's about at 1.5 metres. Okay, if we have a static head of 1 metre, if we're lifting water from the sump up vertically 1 metre to go back to wherever we're pumping it to, all right, we have essentially 0.6 of a metre, 0.6, maybe 0.7 of a metre left to play with to use this pump to get our target flow rate. Okay, if I use the plumbing that is on the inlet and outlet size of this pump, which is 40 millimetre, and I plumb all in 40 millimetre pipe, okay, these are the plumbing fittings that I've got in my friction loss program. On the inlet, this is all 40 mil on the inlet and outlet. On the inlet, I have one 90-degree bend, one valve. Okay, straight into the pump. On the outlet, I have two 90s, two T's, 3 valves, and 4 meters of pipe. You know, manifold, blah, 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 whatever it might be, UV bypass, whatever, you know, going back to the tank. And my target flow is 150 litres a minute because that's what I want to, that's what I want my flow rate to be, 150 litres a minute, okay? So that's about 9,000 litres an hour. 9,000 litres an hour? 100 litres a minute by 66,000, yes, 9,000 litres an hour. So if I use all the 40 mil plumbing that is the standard size of the inlet and outlet on the pump, my head is actually 2.627 metres. So 2,627 millimetres, okay? 2.6 is somewhere up here. I'm going to fall short by at least 25 litres a minute. 1.6 is up here. By at least 25 litres a minute, I'm going to fall short. At least. If I then increase to 50 millimetre, my head comes down to 1.37 or 1.67. Even at 1.67, 1.67 is right on 150 litres a minute. At 1.37, I'm getting a little bit more than 150 litres a minute, and that's where I put the valve on the outlet that I've got in my friction loss sizing. That's where I would use that to control that flow. Okay, if you've got a DC pump, you can use it to control the flow backwards as well. My point being that if you don't have a large enough pipe to get the maximum amount of flow out of, you're going to fall short, because the plumbing and the plumbing fittings and the pipe all produces artificial head to your system. This is a big problem, because a lot of people assume that they should plumb with the size of the inlet and outlet on the pump, and that if it's a 5,000 litre an hour pump, they'll get 5,000 litres an hour. That just simply is not true. The other thing to remember is that wattage does not equal head, horsepower does not equal head, and horsepower does not equal performance. A lot of people ring me up asking for a 2 horsepower pump or a 1 kilowatt blower or something. How much air do you need, or how much water flow do you need? You know, a 1 kilowatt pump can do 100 litres a minute, or it can do 3,000 litres a minute. It just depends on how the impeller and the volute and everything is sized. This pump here, exactly the same volute, so wet end, where the impeller is, right? They change the impeller and they change the size of the pump, and it increases the head. It's exactly the same volute. So it depends on the impeller, it depends on the motor, it depends on the windings, it depends on how they're moving, whether it's magnetic drive, whether it's shaft driven, whether it's belt, whatever, okay? The point being is that don't assume just because you've got a 5,000 litre an hour pump that you're going to get 5,000 litres an hour after you pump through plumbing. The other thing I will say is that as long as you're maintaining your pipe velocities for a certain reason, whether it be solid settling or whatever it might be, you know, you only pay for plumbing once. You continually pay for electricity. If you put the wrong size plumbing in your tank from the beginning, to get the flow, if your friction loss is too high for the pump you want to use, you would have to use a bigger pump that uses more energy to have more grunt to push that same amount of flow, which means that you're going to be using more energy. Now, we continually pay for energy, we only pay for the plumbing once. Do your friction loss sizings. I have a program here that I help people every day to do friction loss sizings with. As a general rule, if you have a general application and you're not putting 1,000 different manifolds and everything in to run all your systems, generally speaking, if you go with the largest size outlet or on the pump or a little bit bigger, and you minimize the amount of fittings and minimize the lift height, generally speaking, they'll have a flow curve on them that, you know, you can at least look at the height overall and say, okay, well, my lift height's this, I'll add an extra 50% to it because I'm going to upsize the outlet from 25 mil to 32 mil or 40 mil or whatever it might be. Your pipe size can get too big, and you can get settling and all sorts of stuff in it. Velocity is important as well, and that's where it pays to know at least that if you have a 1 meter lift height after you pump through plumbing, you're going to have some friction loss, and it just depends on your plumbing size and your plumbing design overall, which will determine what your friction loss is, okay? Do not assume that just because it's a 3,000 litre an hour pump that you're going to get 3,000 litres an hour. This is commonly why people say aim for a 10 times per hour turnover, because at worst case scenario, if the customer really, you know, messes it up or isn't aware of friction loss, if they plumb it and they only get half the flow, 5 times an hour turnover is acceptable and probably the target where most people go to for their filtration, and it still works out. So the system still works for the recommendations that they're making for, you know, turnover of an aquarium or whatever it might be. I do this daily. This is just straightforward engineering of pipe and plumbing systems. It is incredibly relevant, and especially if you are planning on drilling into the tank and putting bulkheads and things in, both for drain lines, which also do have their own separate calculation to work out what flow rates are, and for pressure lines and delivery back to the aquarium, especially if you're putting things like UVs, chillers, things like that on it. Your chiller should have a friction loss, or at the very least you could probably measure it. And then measuring flow is a big thing as well. Flow, flow meters, bucket tests, whatever it might be. Don't ignore your friction loss, okay? If you've got a submersible pump like a wave maker or something in the tank, different story, okay? You're not pumping through plumbing, all right? You're just pushing water. When you're delivering water from one place to another via pipe work, even if it's flexible pipe work, you still have friction loss. There's your Friday freebies for today. I hope everyone has a great weekend. Do yourselves a favour, go out of a weekend, buy the fish, and if it is aquacultured, even better. I hope that everyone in the aquarium industry sells loads this weekend, has a very busy weekend. If you are unlucky enough to be on call or on site for an aquaculture farm or an aquaculture facility, I very much hope that your weekend is uneventful, and if something does go wrong, may the pumps come back on quickly for you. Have a great weekend, have a great Saturday and Sunday. Do please try and stay out of the heat. There is a heat wave coming. Look after your fish, keep an eye on your temperatures, and keep an eye on yourselves as well. Air conditioning is a godsend. Drink lots of water, take care of yourselves, and yeah, have a great weekend. See ya.